The Lucas drone. How the U.S. military uses low-cost attack drones. Introduction. Warfare is changing rapidly. In the past, wars were fought mainly with tanks, fighter jets, and large missiles. Today, small autonomous aircraft called drones are becoming some of the most powerful weapons on the battlefield. One of the newest examples is the low-cost Uncrewed Combat Attack System, also known as the Lucas drone. This drone has recently been deployed by United States Central Command, the U.S. military command responsible for operations in the Middle East. Reports indicate that these drones have been used in military operations related to Iran and other strategic regions. They represent a major shift in how modern militaries conduct precision strikes. But what exactly is the Lucas drone? How does it work? Why is it important? And why is the U.S. military investing heavily in these low-cost autonomous weapons? Let's explore everything you need to know. 1. What is the Lucas drone? The low-cost Uncrewed Combat Attack System is a small attack drone developed for the United States military. It is designed as a one-way attack drone, which means the drone itself becomes the weapon. Instead of returning to base like a normal drone, it flies directly into a target and explodes. Because of this, it is sometimes called a kamikaze drone or loitering munition. The system was developed by the American defense company SpectreWorks. Unlike large drones that cost millions of dollars, the Lucas drone costs roughly $35,000 per unit, making it extremely affordable for military operations. This low cost means that many drones can be used in large numbers during an attack. 2. Why the U.S. military created the Lucas drone. The development of the Lucas drone was influenced by modern conflicts where cheap drones have proven extremely effective. One important influence was the widespread use of drones similar to the Shape 136, an Iranian-designed attack drone. These drones are simple, cheap, and easy to produce. Because of this, they can be launched in large numbers. Military analysts noticed that traditional air defense systems were struggling to stop massive waves of cheap drones. For example, one missile used to intercept a drone can cost hundreds of thousands of dollars. But the attacking drone might only cost tens of thousands of dollars. This creates what experts call a cost imbalance in warfare. To address this, the U.S. military decided to build its own inexpensive attack drones. The result was the Lucas system. 3. What the Lucas drone looks like. The UCAS drone has a simple but distinctive design. Its shape is very similar to the Iranian-shaped drone. Key visual features include delta wing. Designed drone uses a triangle-shaped wing, known as a delta wing. This design improves stability and allows the drone to fly long distances efficiently. Rear propeller. Unlike jet aircraft, the Lucas drone uses a small propeller engine mounted at the back. This propeller pushes the drone forward during flight. Compact. The drone is relatively small. Length, about 10 feet. Wingspan, about 8 feet. Because of its small size, it can be transported easily and launched from multiple platforms. Explosive payload. Inside the drone is an explosive warhead weighing roughly 40 pounds. When the drone reaches its target, it dives and detonates. 4. How the Lucas drone works. Operation of the Lucas drone involves several steps. Let's break down the process. Step 1. Launch. Drone can be launched in several ways. From a ground launcher, from a mobile truck platform, from a ship deck, using a catapult or rocket-assisted launch. In one demonstration, a Lucas drone was launched from a U.S. naval ship operating in the Persian Gulf. This flexibility allows the military to deploy drones from many locations. Step 2. Navigation. After launch, the drone navigates toward its target. Navigation systems may include GPS guidance, pre-programmed flight routes, satellite communication systems. Drone can fly hundreds of miles before reaching its target. Some versions are estimated to have a range of up to 500 miles. Step 3. Loitering. The important capability of these drones is loitering. This means the drone can circle an area while waiting for the right moment to strike. During this time, it can search for targets such as radar systems, military bases, missile launchers, vehicles, infrastructure. Once a target is confirmed, the drone dives toward it. Step 4. Impact and explosion. In the final stage, the drone crashes directly into the target. The onboard explosive warhead detonates on impact. This destroys or damages the target. Because the drone is used only once, it does not need complex landing systems or expensive materials. 5. Why the U.S. Central Command uses Lucas drone. As the United States Central Command also called CENTCOM, oversees military operations across the Middle East. 5.3 Flexible deployment drone can be launched from many platforms. Military bases, mobile vehicles, naval ships. This makes it difficult for opponents to predict where the attack will come from. 6. Role of LUCAS in modern military strategy. LUCAS drone reflects a larger shift in military thinking. Instead of relying only on expensive weapons, modern armies are developing large numbers of cheap autonomous systems. These systems can saturate enemy defenses, conduct reconnaissance, destroy critical targets. This strategy allows militaries to apply constant pressure on opponents. 7. The task force behind the drone operations deployment of Lucas drones is connected to a specialized military unit called Task Force Scorpion Strike. This unit operates under United States Central Command. Its mission includes operating drone squadrons, conducting remote precision strikes, deploying autonomous weapons systems. Task force represents the future of drone-based warfare. 8. Technology inside the Lucas drone. Even though the drone is relatively simple, it still uses advanced technology. Important components include navigation systems. Drone relies on satellite navigation to travel long distances. Communication systems. Some versions may use satellite communication networks for control. Autonomous software. Autonomous navigation software allows the drone to follow programmed routes. Lightweight materials. Drone is built from lightweight materials to increase flight range and efficiency. 9. Advantages of kamikaze drones. Kamikaze drones like LUCAS have several advantages over traditional weapons. Lower-cost cheap drones allow militaries to conduct more operations without spending massive budgets. Precision strikes. They can target specific objects with high accuracy. Reduced risk to pilots. Best the aircraft is unmanned. No human pilot is at risk. Long and ransom drones can remain airborne for hours before striking. 10. Challenges and controversies. Despite their advantages, these drones also raise concerns. Some experts worrying about escalation of drone warfare, increased use of autonomous weapons, ethical questions about remote attacks. As drone technology spreads around the world, many countries are developing similar systems. Conclusion: the low-cost Uncrewed Combat Attack System represents a major shift in modern military technology. Developed for the U.S. military and used by United States Central Command, the Lucas drone is designed to be inexpensive, scalable, autonomous, effective in swarm attacks with a range of hundreds of miles, and an explosive payload capable of destroying key targets. This small drone has become an important tool in modern warfare. More importantly, it signals the future of military strategy. Instead of relying only on expensive missiles and aircraft, nations are now building large fleets of smart, low-cost drones capable of overwhelming enemy defenses. As drone technology continues to evolve, systems like Lucas may play a central role in future conflicts across the globe. The era of autonomous drone warfare has truly begun. Thanks. Like, share, follow and subscribe this Tech in Minute.